Hi, after talking so much about statistics and data, I want to talk a little bit about how one goes about and gets data. Starting with a talk on the scientific method. What is the scientific method? First, you need to come up with an idea. It's called a hypothesis about how things work. Why does the moon do what it does? What do grasshoppers really do when they're not being looked at? Whatever. You come up with a theory. You think of some consequences of it called predictions of this hypothesis. If things are the way you imagine they are, what does that mean? What sort of things result from your idea? You think of an experiment that sees whether these consequences actually occur. This is what makes the difference between just ideas and theories and science. Science is what's called disprovable. If it's truly a scientific idea, there's a way to prove that it's not true. You say the moon is made of cheese, therefore if you go up, that's a hypothesis, the prediction, if I went to the moon, I could eat it and it would be delicious. You think of an experiment. Go to the moon and eat some of the rocks up there and see what happens. Now, a lot of times what we're doing is we're comparing different things. We say, smoking is bad for you. Oh, well, what does that mean? Well, we say smoking is bad for you. What are some consequences? Well, if a person smoked a whole lot, they would have more likely to have lung cancer. What kind of experiment could we do? Well, we could have some people or some animals smoke a whole lot of cigarettes, and then I would predict that they would have more chances of having heart disease and lung cancer, or whatever your predictions are. What's an experiment? Well, an experiment has to have an experimental group and a control group. You have some group of people are smoking a whole lot of cigarettes, and the control group are the people who don't smoke cigarettes. You have to have something. You can't just give everybody cigarettes. You can't just say, I think that wearing hats in the class is going to help the students, so I'm going to give everybody hats. No. You have to give some people hats and some people not have hats and see if it makes a difference. Now, the groups must be the same in all ways except the one being tested. So you can't just give hats to the stronger students in the class and not hats to the other students. That's not fair. You have to, make sure that the people with the hats and the people without the hats are as similar as possible. The only difference is that some of them are wearing hats. Now, the question is, if one group gets a treatment, the other one has to get a placebo. If you're going to have people smoke cigarettes and see if this affects them, to some degree, the control group should be doing something that is like cigarettes, but not cigarettes. You should have some group smoke tobacco and some group smoke not tobacco. You should have some group wearing... it's kind of tricky. You have to think of a way to fool the people so that they don't know. And the best kind of experiment is called blind. That the control group is ideally blind. They don't know if they're wearing hats. If you're giving medicine to people, you give medicine to half the people, you give a placebo to the other half. You give fake medicine to them. This can be very tricky if you want to see how well surgery works, because you have to make it so that the people in the group don't know whether they're the group getting surgery or not getting surgery. So you kind of have to cut them open and then not perform an operation so that everything else can be the same. Which is why it's very, very hard to get studies on this sort of thing. Ideally, the scientists must be double blind. The scientists should write down somewhere which bottles of pills have the drug in them and which bottles don't. And then they hide that information, they shuffle them all up, and they randomly give out bottles of either pills or fake pills, which look the same, to their patients. And the ones who take the pills, will tell you how they end up feeling, and the ones who take the fake pills will tell you how they're feeling. They don't know whether they're getting real medicine or not. The fact is that taking fake medicine helps people a lot. Taking sugar pills have been known to do all sorts of things. They cure headaches. They make people feel better. They cure infections. Some percent of the time. So you have to compare any new medicine to fake medicine, not to no medicine at all, because if you go to the doctor and they give you something, it tends to make you feel better. Just the mere fact that you got something, even if it's an ineffective medicine. Now, the scientists shouldn't know which is happening. Only when the experiment is done should they then look and say, oh, of these people, can we see which ones are having a result or not? Or is it random? Now, you do the experiment, you make observations, and you collect data. Now, if the data confirms what you said, if the data goes along with what you predicted was going to happen, maybe your hypothesis was right. Maybe make other predictions, conduct other experiments, continue to check. There is nothing in science that is so certain that it doesn't keep getting tested. At the very least, in physics, you test whether there's gravity. Why? Well, it's a good experiment. And every time anyone's ever tested gravity, they have successfully proven that there is, well, not proven. But to be science, you have to always be putting yourself out there and risking being wrong. If, however, the data comes out different from what you predicted, your hypothesis is wrong, or you screwed up the experiment, which is always a possibility. But you need to come up with a new hypothesis that explains either what I said previously was wrong, that's not the way things work, or I think something went wrong with the way I conducted the experiment. So this is the scientific method. You've probably seen this before, but it's really, really important to understanding any sort of information, scientific information that we're given. It should be the result of this. It's not just people in lab coats making up ideas. They make up ideas. They think about, how can I prove myself wrong? How can I... you're really putting yourself out there all the time. You say, I think this pill is going to help people. And you say, okay, I'm going to give those pills to some people, and I'm going to give fake pills to other people. You're not going to know who is who, and then we'll see who gets helped. And in the end, we'll look at everybody's blood pressure or chance of lung cancer or whatever, and only at the very end will we decide whether the people who ended up doing well were ones getting your pill or not. So this is the way science is supposed to work, and it's really good to know.